In my time as a network administrator, the most often thing I heard was, hey, this is probably the network's problem or it's a networking issue. And most of the time it really wasn't, but it's really easy to blame the network when you consider the network as this mysterious thing most people who are using it don't understand. You just plug into it or connect to it via wireless and it's always there and it always works, of course. So that's the thing I often have to deal with, and that's what this scenario is really centered around, is this concept of, hey, I have this issue and I'm blaming the network. In this case, we've opened up the file tickedoffdeveloper.pcapng, and we call it that because we have a developer who's created an application that is transferring some data from a store to a central database, and it's not working properly, and they say it's the network's fault. It's definitely not their fault. So our use case here is we want to actually prove that it's not the network's fault. And at this point, we don't know. Maybe it could be. We're going to try to prove that it's not the network's fault and it's actually the application's fault. This is probably the number one reason why I initially learned packet analysis, was because I know the packets wouldn't lie. And if I can understand how to dissect and understand what the packets were saying, then I could very easily prove when the network was or wasn't at fault. Of course, if it wasn't at fault as the network guy, I didn't have to worry about it. And if it was at fault, then I knew where the problem was and I could fix it more efficiently. So let's dig into this tickedoffdeveloper.pcapng file and see if we can figure out what the problem is. Now, in this case, we don't have a lot of packets to deal with. We've isolated this to a single communication stream, and we can see very clearly we have FTP traffic present. We see FTP listed in the packet details window, and we see a lot of FTP-related commands here as well. Of course, this begins with the TCP three-way handshake. In this case, it's between 172.16.16.128, which we assume is our store, and 172.16.16.121, which we assume is our central server that's receiving the data in this case. Now, we know we're transferring a file, and we see that we have FTP data going on. And the good thing about FTP, at least from an analysis perspective, is it's clear text, and we can very quickly find what we're looking for. FTP, as you may have seen earlier, works based upon commands. So in this case, we have a user command followed by the username, which is salesexfer. We have a pass command followed by the actual password here. So we can actually use this to our advantage and create a filter based upon this to find a file being transferred. So let's actually do that. I'm going to click down here into the FTP section, expand this, and where it says request command, I'm going to create a filter based on that. So I'm going to right click this, go to prepare as filter, and select it. And up here at the top, I put FTP request command equals user. Now, I don't actually want to filter based upon the user command. I don't really need that. I know we're uploading a file, and I know that the FTP command for uploading a file is store, S-T-O-R. So I'm going to modify that and tell it to show me the store command and hit enter. Now in this capture, it's only a single file transfer, so it filters down to a single packet, which in this case is packet 64, and we see we are storing the file STORE 4829-032222.010.csv. So this is the CSV file that the remote store is uploading to the centralized database server that's being then inserted into the database. So we found where that file transfer is happening, and we can dig into that just a little bit more. Now, if we want to see the data that's associated with this file transfer, your initial thought might be to right-click this file. We'll go to follow TCP stream, and hopefully we get the file contents there. But you're actually going to see that doesn't happen. We don't see that data. In fact, we see FTP commands and responses, but we don't see the file being transferred. Here's the store command, and then we don't really see anything else until it says transfer is okay. So where's that data at? Well, remember that FTP has two different channels for communicating. It has a control channel, which has commands and responses, and it has a data channel as well. And it's that data channel that we're interested in because that's where the actual data transfer that's happening occurs. So that's what we want to dig into next. Now, there are a couple of ways to go about that. I think the easiest way, since this is an isolated scenario, is to look for the store command. So we see it here, it's packet 64. Notice we're skipping some things here because we filtered a TCP stream, so it says stream equals 0. I want to go ahead and clear that out. And once I do that, you see we get quite a bit more information here. We get to see more packets, and that's where we see this FTP data channel opened up, and that's where data is being transferred. So I'm actually going to go ahead and right-click that and follow that TCP stream. When I do that, we see what looks to be something in CSV format, right? We see columns, so we see store ID, SKF, and QTY, so we have SCIF numbers and quantities, and then we see values for those things. Those are just numbers in this case, they're just IDs from a database, but this looks like a CSV file, and you know what? It looks like everything's okay, right? It looks properly formatted, at least from here. CSV is not a very complicated file. That's the benefit of having a clear text protocol to look at, is we can see these things. Obviously not the best from a security perspective because somebody could intercept this. But for our purposes, it helps us see what's going on. So we do see that we have the CS file being transferred here, and for the most part, everything looks okay. However, we don't know that for an absolute fact. The numbers could have been messed up. Any number of things could have happened. Some numbers could have been transposed, and we want to validate that this is the actual file that we're expecting to be transferred, and it's being transferred intact. So the way to do that is to extract these contents into a source file, create a hash of that file, and compare it to the hash of the file that the developer provided us to ensure that the file is actually correct and uncorrupted. So that's what we're going to do next. To copy this file out of Wireshark, the process is pretty straightforward. We're simply going to select a single side of the conversation, which in this case there's no bidirectional communication, so that's pretty straightforward. We want the side from client to server. We want to save the data in its raw format in this case, and we're going to go ahead and click Save As. And then just give the file a name, and we'll dump it. In this case, we'll just dump it straight to the desktop. This seems like a good place as any. I'll call it store.csv, and we should be good to go there. Now, we could just open up the file, and ideally, like if it opens up, then it's probably fine. But again, we want to verify that it's not been manipulated and transferred, so we want to take a cryptographic hash of it, compare it to the source hash that the developer gave us, and hope that everything matches up together. So let's do that now. Compare the hash of this file to the known good hash we have. I could download a utility. There are graphical utilities and other utilities that you can use to generate hashes, but there's actually a utility built into Windows that most I don't think realizes there that will do this for you, and it's actually the cert util program. So I can use it with the -hash file option and go ahead and point it to our store.csv file and tell it to give us the MD5 hash of that file, which is what I've done here on the screen. Now, in this case, we can compare this to the file hash that I provided in the initial lab prompt, which is one the developer provided to say, hey, if your file matches this hash, then we know that the file is fine. And in this case, if you compare those byte for byte, they are the exact same. This is the same hash that appears that the developer provided us. So what we've confirmed here is that the network isn't the issue. We've captured these packets from the server's perspective, and we've extracted this file, so we are seeing the file as the server sees it, and the server sees it as it is. So if the database is showing incorrect information, it's actually likely the fault of the application that's processing that information and dumping it into the database, or in a way that the application is maybe reading the data out of the database as well. But nonetheless, we know the network is not an issue. Now, that's a bit of a change from the previous exercises we've been looking at, where we know the network maybe is the issue or a specific host is the issue, and we're using the network to pinpoint it. In this case, we did this exercise to determine that the network is indeed not the issue and that the application itself is, and we were able to find that by taking a file hash and comparing it against the known good hash.